Okay.
Yeah. So if we could just do some examples on that, I think that'll help.
Can you make one up?
Yeah. Well, so
I'm having a
he
little
just,
hard time picturing the problem.
yeah, so they're graphs, they're parabolas. Um, and then like whatever the vertex of that parabola is, we plug into the vertex equation,
Okay.
form equation, yeah.
Okay. Let me get my book out.
Sure.
Just to give
Okay.
you some problems to refer to.
Sure. Yeah.
First of all, what's the vertex format? Tell me what that is.
So it's f of x is equal to a parentheses x minus h squared plus k.
Notice again that it's always x minus h.
Yeah.
It actually started out with y minus k, but the k was moved to the right side of the equation. That's how it ends up with plus k.
Okay.
Everything is always x minus h and y minus k. Doesn't
Okay.
matter whether you're talking parabolas, ellipses, circles, whatever. So this is the format that if we can get this parabola into this format, then I'll know where the vertex is. So let me draw a parabola
Okay.
and let me label some points on that parabola.
Sure.
How many points did they give you? 3?
They gave us just two. So like the vertex and then like another 2 points on the graph.
Okay. So let me
Yeah.
make up a vertex here.
Okay.
Let's call that vertex 2 comma minus 3.
Cool.
And then I'll make up a point up here. We'll call it 6 comma 4.
Okay.
Okay. So if we want to come up with the equation of this parabola, I plug in everything that I know. In other words, let's start by plugging in h and k.
Okay.
What's h?
Uh, the high or well,
The x coordinate of the vertex.
okay, so two.
Okay.
And then K, is that the Y?
That's the y coordinate of the vertex.
Okay, that
Okay. So
makes
I
sense.
know that much.
Okay.
Okay. Now, can I solve for a? In other words, I want my equation to end up being sum a. It's going to be y equals sum a times x minus 2 quantity squared minus 3. So I have to solve for a still. I don't know what a is yet. How can I solve for a?
Um, well, to solve for A,
Take
let's see.
that point right there. You have to find a different point,
Okay.
plug it in for x and y, and that will allow you to solve for a.
Oh, that makes sense. Okay.
So what's the equation?
So, okay, so it'd be 4 is equal to 6
Now,
parentheses, or just 4.
a, we don't know what a is yet. That's what we're solving. And then
Right, and then
6 minus
6
2
squared.
squared minus 3. Now we can solve
Mhm.
for a pretty easily. We
Okay, cool.
4 equals 16a minus 3. So
Mm-hmm.
that's 7 equals 16a. A equals 7/16. Now what's my equation?
Okay, so now it would be y is equal to 7 over 16 um, times 4 squared minus 3.
Well, you always want a y and an x in your final answer. Your final
Uh,
answer, you want to go back and put the x back in.
and then minus 2
Quantity squared
squared minus
minus
3.
3. Notice that that equation only has two variables in it, x and y.
Mm-hmm. Okay.
In other words, that is the proper equation. If you gave me this equation, I could graph it. I could graph the parabola. That's only one parabola that can possibly be.
Okay.
But it's a lot like when, well, it's like, it's a little like if you have y equals mx plus b,
Mm-hmm.
and I know the slope is 2, so I now have
Uh-huh.
y equal 2x plus b, and I know a point is at 1 comma 2. Well, that point allows me to solve for b. By
Okay.
putting that point in for x and y, I get 2 equals 2 times 1 plus b. Well, that
Mm-hmm.
means b is 0. So my
Okay.
original equation must be y equals slope,
Mm-hmm.
that, exactly. That's it.
Okay. Okay.
There's no
That makes.
b. The b was 0, but if
Mm.
b would have come out to be a number, like say 1 plus 1, well then that's my equation. Notice my equation has one y, one x, and no other unknowns.
Okay.
Same principle for what we just did.
Mm-hmm. That makes
How do
sense.
I
Yeah.
go back? Are you familiar with this notebook problem?
A little bit.
How do I
Try
go
that
back?
back arrow top left.
That kind of worked.
Yeah, and then we could just.
That's the page right there. Thank you.
Mm-hmm. Yeah,
Never do
definitely.
that. Yeah, when you hit the back arrow, it shows you a series of pages. That was
Yeah.
for a previous student a
Oh, that's
couple
cool.
sessions ago. There's arithmetic sequences for a previous student. There's 3
Awesome.
equations and 3 unknowns. There's a linear programming problem. But if I want the page you and I were on, I just click on that.
Cool.
Thank you. That was helpful.
Yeah, definitely.
All right. Um,
Hmm.
so let's see. What you want to do with the last 15 minutes here?
Um,
We could do
I'm
another
not
problem like this. You want to do a problem like this? I'll make up the points and let you see if you can take it from start to finish.
sure we could do that. Yeah. Oh, yeah, so we took the Unit 1 test in math probably a week ago,
Uh-huh.
and actually, I think it was actually last Wednesday, I think, or something like that. But yeah, so probably 3/4 of the class got low D's and some F's, and then I got mine back and got a solid B on it, so I was
Good for you.
really happy
Good
about
for
that.
you.
Yeah.
Yeah, no, I'm detecting more math knowledge out of you.
Yeah.
I
I
am.
feel like I'm understanding this a little more.
I can see that as we
Mm-hmm.
progress.
Yeah.
Um,
Yeah.
all right, there's your vertex.
Okay.
And there's another point that's on the parabola.
Okay.
So how do we come up with the vertex format of this equation?
All right. So we could do, so it'd be f of x is equal to a parentheses x minus 5.
No, let's start, just to be safe.
Oh, x minus h plus k. Okay.
I like doing that
Cool.
step. I always like beginning math problems with the general format.
Okay.
For one thing, if you do that, you write it often enough that you're never going to forget it.
Right.
Okay. Whereas if I'd have put in x minus 5, that would have been specific to this problem only,
Mm-hmm.
and I might not remember this general format next time. So
Okay.
always, no matter what the problem is, I always think you should start it with the general format. Now,
Sure.
let's take the vertex and plug that in.
Mm-hmm.
Instead of calling it f of x, I'm going to call it y. You do understand they're the same thing, right?
Yeah, definitely.
Only reason I'm calling it y is because we're dealing with x and y coordinates over here.
Okay.
It's going to make it easier to figure out. So what's y? What's the first step?
So we know the vertex. Like we're gonna plug the vertex in.
Okay, so let's do that. So x
Okay.
minus 5 quantity squared
Mhm.
plus 4. Okay,
Yeah.
now that tells us everything we need to know except a.
Yeah.
So how do I solve for a?
All right. So we were to pick the second point on the graph.
Okay,
So it'd be -1 is equal to a parentheses 2 minus 5 squared plus 4.
okay, let's expand,
And then it would,
expand.
yeah, then be -1 is equal to um 2a minus 5.
Now
No, we would
do
do
the
the
2 minus,
parentheses
do
first.
the 2 minus 5 and then square it.
Yeah, so it'd be 9. So 9a plus 4.
A plus 4, okay. Now we
And
get
then
9a equals minus 5.
it would be -5 over 9
Okay, so
is
what's the
equal to a.
final? Now we can go back and use f of x.
Cool. And then it'd be f of x is equal to -5 over 9 parentheses x minus 5 squared plus 4.
Yeah.
Cool.
And notice that fits our picture. We have a downward opening parabola, so
Mm-hmm.
our quadratic should have a negative sign in front of the x. Well, by the time I square that and put that negative sign in front of it, I do have a negative sign in front of the x.
Yeah.
So it makes sense. And the
Mm-hmm.
previous one was opening up, so it made sense.
Cool.
I just noticed something. No.
Mm-hmm.
Whenever you get close to it, oh, that's the same page. Why does it do this? Can you see that
Um,
picture down there?
I,
What's
I
the,
can, yeah.
what's the advantage of having that when I pass the cursor over it? It just is in my way and it's the same page. It's not like it's a previous page. If it was a previous
Right.
page, I'd kind of like it. But,
Right. Well, I think what that's for is if you have multiple windows, you can pull that up and it shows the image for each window that you
oh,
have.
I see. I see.
Yeah,
It just shows you what each window has, yeah.
exactly. Yeah.
And notice up top here it says notebook syncing.
Huh.
This
That's,
is more than just a notepad.
yeah.
The fact that it's syncing up, it must be syncing with the cloud or something. I don't know.
Maybe something off your phone? Is your phone connected to the
No,
computer?
no. It'll say syncing for a while, and then once it gets synced up, it'll stop saying that. But
That's weird. Huh.
it is kind of weird. I haven't quite figured out what the syncing is. What is it syncing with?
Maybe put your cursor on it to
Ah,
see
see,
like
it
what it
said sync
means. Yeah.
complete.
Yeah. That is weird.
Yeah,
Huh.
sync complete. Hmm.
Yeah,
Well, it
I'm not
makes me
sure.
think that once I've got my sync complete, that I'd be able to
Hmm.
do stuff that I couldn't do while now it says syncing.
Yeah.
Incomplete. Yeah, I got a feeling that once the sync is complete, there's more power on this thing. I just haven't figured out what it is.
Right.
What I,
Yeah, I haven't either. That's odd.
uh,
It's kind of odd.
all right, let's see if I can think of any modifications to this.
Yeah.
I kind of can think of one.
Okay.
This time,
Hmm.
3 points determine a parabola. Any
Okay.
3 points. I don't have
Okay.
to have the vertex. If you have the vertex, then you need only one other point. But let's say I have these 3 points. 1 comma 3,
Hmm.
2 comma 1. And
Hmm.
what's that? That's about 8 comma 2.
Yeah.
Okay? Now, how am I going to come up with the vertex form of this parabola with those 3 points? Where do I start?
Well, with the equation, so f of x is equal to a parentheses x minus h squared plus k.
Okay. Now, notice that besides the x and the y, there are three variables there I need to solve for, a, h, and k. Once I
Mm-hmm.
solve for a, h, and k, I'll have my equation, right?
Okay, yeah.
Well, I have 3 points that I can plug in for x and y. So here's one equation. 3 equals a times 1 minus h squared plus k.
Mm-hmm.
That's for this point right here.
Okay.
And then for this point here, I get 1 equals a times 2 minus h squared
Mm-hmm.
plus k.
Okay.
And finally, for this third point over here, I get 2 equals a times 8 minus h quantity
Mm-hmm.
squared plus k. Now
Okay.
notice what I'm looking at. I'm looking at a system of 3 equations and 3 variables, a, h, and k.
Yeah.
Well, I know you've done this because I remember we had a session a couple weeks ago where you had 3 variables and 3 equations.
I remember that. Yeah.
And so I would be able to solve for a, h, and k
Okay.
using those 3 equations and 3 variables. It takes some math. In other words, you got to expand this a little bit. It's not going to
Mm-hmm.
be super easy to do, but
No.
it's doable. Whenever you have the same number of equations as you have variables, it's doable. You know, I mean, I suppose you have the situations where there's no solution or infinite number of solutions, but usually you
Mm-hmm.
get a unique solution when you have that.
Right.
3
Yeah.
equations and 3 variables. And
Mm-hmm.
we don't need to go through that now on how to do it, but it can be done. And suffice it to say that that's all you need to know is that it can be done. And so
Okay.
I eventually solve for a, h, and k, which leads me back to the equation, which might look, remember your final equation always has the y and the x in it, but let's
Mm-hmm.
say a came out to be a half, h came out to be 3, and k came out to be 4. That would be our
Okay.
final, that would be our answer.
Okay. Yeah.
In other words, I've solved for a, h, and k, and then now I have the proper equation for a parabola, which is y equals some number times x minus some number squared plus another number. And
Mm-hmm.
all I had to do was solve for each of those, a, h, and k. The
Okay.
reason we were only needed 2 points before
Mm-hmm.
is because one of the points was the vertex, which
Mm-hmm.
is h and k immediately. So the moment they give you the vertex, they're giving you 2 of these 3 variables. And then
Mm-hmm.
solving for A, you saw, was relatively easy. But
Right.
they don't have to give you the vertex. They could just give you any 3 points on the parabola, and then you have to use this technique to solve it, because I don't know where the vertex is.
Yeah, me neither.
No, I mean,
Okay.
the 3 points that I gave you there, it would be impossible to say what exactly the coordinates are on that vertex.
Right.
And the only way I'm going to be able to do it is by plugging in my 3 points, creating 3 equations, solving for A, H, and K.
Okay. Cool. That makes sense.
And that's about as hard as they're ever going to get, is this, where
Yeah, I would
you
think
don't
so.
give you the vertex as one of the points.
Okay.
But they have to give you 3 points if they don't give you the vertex as one of the points. In other words,
Mm-hmm.
if I just say, I got a point here and a point there, well, there's lots of different parabolas that can be drawn through those 2 points. I can draw the parabola like this. I could draw it like this. I could draw it like that. You see, there's all kinds of ways to draw it. But
Yeah.
the moment I put 3 points on there, a point there, a point there, and a point there, there's only one way that parabola can be drawn.
Okay.
The vertex is somewhere down there, so that parabola has to be drawn something like that. But
Mm-hmm.
3 point, just like 2 points determine a straight line,
Mm-hmm.
3 points determine a parabola.
Okay.
If they give you 3 points, you can always figure out what parabola they're talking about. It's a unique solution set.
Okay.
Unless the
Cool.
points don't fit together, well, in other words, if they gave you a point there and a point there and some point way over here, now that's an interesting problem. In other words, our 3 points are right there.
Uh-huh.
Does that make a parabola? Maybe.
Maybe, yeah.
Because
It
I could draw
depends.
that parabola really, really flat at the top.
Mm-hmm. And then, yeah, do that.
Through there. So
Right.
I think any 3 points, maybe if I did, well, those 3 points that are on a straight line are not going to form a parabola. So not
Mm-hmm.
just any 3 points, but usually any 3 points will determine a parabola.
Cool. Okay.
All right. Dylan, I'll
Awesome.
let you go, and that way I can get to my 5:30 without being late to it.
That sounds good.
All right.
Alright.
I'll talk to you. I think Wednesday we have a session. Is that right?
I I think so. Do you think we can move that till 7:30? Because we have
Yeah, definitely. Not
okay.
7:30. I can move it to 8.
Sure.
I'm
Yeah, we
not
can move.
back here until 8. Let me move it to 8 while I'm looking at it.
Cool. I just have this scheduled practice on Wednesdays now, so
Oh, okay,
it
cool.
was just canceled last week because of I don't know what, but
Yeah.
yeah,
All right.
they should
I'll,
have it
I'll
this week.
talk to you at 8 on Wednesday.
That sounds good.
All
All
right.
right.
Bye-bye.